Okay, so till now we have discussed last six sessions completely we spent on Python basics and SQL basics. So from today, so we will start discussing on Databricks. Databricks in the sense what today we will focus on the PySpark architecture and Databricks architecture. Okay. So before this PySpark, we for big data analytics we are using Hadoop, Apache Hadoop, and Kafka. So big data, this one, right? But what is the difference between? So why everyone is migrating to Databricks and this PySpark architecture? Because earlier we have, so if anyone worked on big data analytics, so when this cloud was not there. So there we have this big data analytics, right? On premise we are using Kafka, Apache, Hadoop, Hive. So these, so in those tools, they were using map reduce method. So what is this map reduce method? So let me explain, give a brief of this. So MapReduce is a programming model used for processing and generating large data sets in a distributed computing environment. So same. So in here also, PySpark also, we are, this one also, PySpark engine also distributed computing environment only. But the only difference between the MapReduce and this one is, so MapReduce, the reads and writes are every time operates on disk. So every time we have to, so whenever you are going to read, so you have to read from the disk is nothing but storage account. So whenever you are going to write, that time you are going to write to storage account. So whereas the Spark, the big only difference between those Apache's Hadoop and all to the Apache Spark is, so in Apache Spark, okay, this map reduce method earlier and now, so in Apache Spark, we are using in-memory computing. Only the difference. Remaining everything is same. So there also we have worker nodes. There also we have this the what driver node. Everything is same. But there, so what we have, so there we have to connect to storage accounts every time for reading and writing. So now, so in Apache Spark, there here we are not using any reads and writes to the external disk. So in the RAM memory only, so inside the RAM memory only, so we are saving this and we are reading and writing from RAM memory only. So the latency is very less in Apache Spark compared to this map reduce, earlier cases. So we'll see, so what is this map reduce, how it is working. 1 minute, guys. This is the problem. Okay. So here you can see, so what he wants. So he wants, so how many deers in this list? Okay, so he has given some input. So it has three set of inputs. So one first input set is deer, beer, and river. So second input set is car, river. So third one is deer, beer, car, beer. So these are three inputs. Okay, so in this three sets, this one is first set and this one is second set, this one is third set. But at last what he want, how many beers in this one, how many rivers, how many cars, and how many deers in this input, he wants to know. Okay, so in earlier, so we are using map reduce, right? So first phase is map phase and second phase is reduce phase. So in map, so what is happening in map phase? So we are splitting the input into three. Okay, so first set is this one, deer, bear, river, and second one this one, car, river, and third one is this. Then in map phase, what we are doing? So we are giving key value pairs. Okay, so in map phase, the input data set is splitted into smaller chunks. Okay, so this one is smaller chunks, right? So it is input data set, and we are splitting it into smaller ones. Okay, then a mapper function is, we have mapper function. So mapper function processes each chunk. These are the chunks, right? It will process each chunk and it generates key value pairs. Key value pairs as immediate output. So this is one. This is first output. This is map phase, and this one is reducing phase. So first phase is mapping phase, and next phase is reducing phase. So in mapping, what mapping function is doing, so it generates key value pairs. Okay. So for there one, so this is the key, here is the key, and its value is one. Here also beer we have na beer key and value is one. River one, so value is one. Here every for everything, so for every key value is one only. So in mapping function, what mapping function will do defaultly? So in default case, what it will give you, it will assign value as one to each key. So here we have car, river, right? Car. So the key car has only one value. The other car key car has only one value. River has one value. So every value is deer car bear, right? Deer car bear one. Now shuffling will happens in second phase. Second phase is nothing but reducing phase. So now what we will do, shuffling. So how many beers are there? From here we have one beer, right? So here beer one, and where we have, yeah, this beer. So from here we have beer one, right? Beer. And car. So we don't have car from this set. From this set we have car, a car, and car. So from here we have deer one, and from here we have deer one, and river. From these two sets, from first two sets we have river. So shuffling will happen. So here the first key is beer key, the second one is car key, the third one is deer, and last one is river. So alphabetically, so the keys will be shuffled. And so from this mapped function we will have the output now. So from this output this will be shuffled. Now reducing, shuffling completed, reducing. How many are there? So one plus one. So the value sum is happened. Sum will be one plus one, right? So two. So now reducer function. So what reducer function will do? So the key value pairs from the mapper are shuffled and sorted based on the key. So here we are doing shuffling, right? Based on the key we are doing. So first key is bear. It is alphabetical. Okay. So what we are doing, the key value pairs from the mapper are shuffled and sorted based on the key. A reducer function, what it is doing, the mapping function generated key value pairs, and the reducer function aggregates. Now aggregation is nothing but, so how many values are there, it is going to do summation. So aggregates are process the values corresponding to one minute, corresponding to each key. You understood right now? So now the reducer function is doing the aggregation, aggregation. Okay. How many? 1 plus 1, 2. Here aggregation, 1 plus 1 plus 1, 3. 1 plus 1. So here key is beer, right? Key is beer and value is summation, aggregation. Key is car and aggregation. Key is deer, so aggregation 1 plus 1, 2. Key is river and aggregation 2. So now this final result, so reducer function also completed. So now what is the output now? Beer 2. So final result. So here we what converted to small chunks now. Now these chunks are collected at last, and the output is this one. So all chunks are grouped together. So key beer 2, car 3, river, deer 2, and river 2. So now from the input to output, so this is called latency. From input to output, so how many times we have read and written? So here one time we read the data. Okay, so one time we have written to the, so mapper function will write it to the disk, right? So one time it read the data and one time it written the data. For shuffling also, so for shuffling also from the disk they will read, right? So second time it read the data, and second time, so to the reducer function, second time they are written. Two times read and two times written to the disks. Okay, so external. So this the latency will be very high in this one. Latency is nothing but, so to get output from, to get final result from the input, so how much time it took, so that is called the latency. Okay, to get the response from the, so from the action started to get the response, the time taken is called a latency. So it is happening, the everything reading and writing is happening in through the disk, right? External disk. So it will take time to reads and writes. But whereas in our Apache Spark, so same thing will happen. Same thing will happen, but it is inside in memory. So we will have RAM memory, right? So inside, while creating the cluster, we will provide this much memory, right? So inside that RAM memory only this will happen. There are no external reads and writes. So reads and writes are there, but to the memory location only, to the RAM memory, random access memory location only. So it is very fast. That's why everyone is attracted to this Apache Spark, where we are getting the latency in microseconds. So 1 lakh millions of records will be processed within 2 to 3 seconds. Whereas in earlier we have Apache, Hadoop, these na they will take minutes. Whereas our Apache Spark now it is in-memory computing tool, so it is taking 2 or 3 minutes seconds only. Okay, yeah. So early, I want to show you. So earlier, how why everyone converted to this Apache Spark. Okay, so every system, AWS, Athena, they call. So in GCP also we have Databricks kind of tool. Microsoft Azure also we have Azure Databricks. So every data processing tool nowadays. So every big data analytics tool is using this Apache Spark only. Why? Because of this in-memory computing. Okay. So in-memory computing is nothing but it refers to processing data directly in RAM, okay, instead of reading and writing to external disk. So this approach significantly speed up. It doesn't mean it means latency is very less. Okay, yeah. So what is the advantage of this Apache Spark now? So due to this in-memory computing, so the advantages are faster processing. Exactly, because no reads and writes to external memory, because since we are using RAM only for this memory, these reads and write, we are using RAM only, and reduced latency. Yes, so reduce no need for frequent disk writes and writes, right? So we are not accessing external disks for reads and writes, so latency will be less. Okay, and real time analytics. Okay, so real-time analytics means earlier we have this big data analytics tool, but frequently we are accessing to the external storage. So if you want to see the real-time process, then it is very difficult in those big data analytics earlier whatever we have, because they are frequently we have to connect to external storages, so their latency is very high, and it is taking almost, if you have millions of records, it is going to take 20-30 minutes to complete. So that time for real-time analytics, it is not suitable. So whereas our Apache Spark, it completes in 2 to 3 seconds. That's why, so for real-time analytics, everyone is choosing Apache Spark only. Okay. Mm, yeah, 1 minute, guys. So first discuss about, so this one is something about, so why we migrated from Apache Hadoop, Kafka, so those tools to Apache Spark, why we have migrated. So we have Hive and Hadoop, right? So from why we are not using those, and why everyone is migrating to this Apache Spark architecture, because of this in-memory computing only. Everything is else is same. There also we have distributed network, distributed computing system means there also we have workers and drivers. Here also we have, but only the difference is there we have external disk, here we have in-memory computing. Okay, so now let's discuss about this Apache Spark. So Apache Spark, why everyone is attracted? Because it is open source. Open source means, so it is we don't need to pay for license, and using this Apache Spark, no need to pay extra money. So this is open source. So everyone, any developer can use. So it is on online. It is available for free. Okay, and open source and distributed computing system. So distributed computing system means it won't work with one node. So we can give, so while creating the cluster, we can give a handsome amount of workers. So if it is the workload is very high, I mean, if you are working with heavy workloads, then you can give worker nodes are 3 or 4. Okay, so we can use this distributed computing system is to complete one task, we have many executors, many workers. So we are distributing the work among the workers. That's why it is distributed computing system. Okay. And so because of this distributed computing system, because we have this master slave approach, I will explain what is master slave approach. So because of this, the process is faster processing. And next, yeah, so the key features are, yeah, what are the key features? Speed, yes, absolutely. Speed is high because of this in-memory computing. So it uses in-memory computing to process large data sets. It works quickly. So speed, the feature is speed. Scalability, yes, scalability means, so if you want, if the workload is very small, so if the records number of records is less than 10K or not more than 1 lakh, then we can use only one worker node. So if the so sometimes, so you may get a large data set. So for some tasks, so then that time you can increase the cluster size to 2 or 3 worker nodes. So we can auto scale the these machines. Okay, so we can auto scale this worker nodes. So that's why. So this scalability is there. So we will not waste our resources. Okay, so we will pay for if our workload is very high, so we can increase the clusters, I mean cluster size and worker nodes. If the workload is very less, and if it is medium data set, medium number of records are there, then we can reduce the size, memory size, and this cluster configuration we can reduce, and the worker nodes also we can reduce. So that's why. So this scalability also one attracting feature. And the flexibility. So the flexibility, Apache Spark allows. So Apache Spark does not allow only one language. It allows multiple languages. First, it built on Scala only. Earlier, they are using Scala only. Okay. So then, so they designed to support. Now Apache Spark is supporting Python, and if you are good at Python, you can use Python for writing your notebook, so your coding. If you are good at SQL, so then you can convert, you can use SQL also in our notebooks. And if you know Scala only, you can use Scala. So if you know R language, you can use R language. But I suggest you to write your code in Python only, because Python is default language for Apache Spark. That's why we call it as PySpark, right? So Python is native language for this Spark. That's why. So I just suggest you to use Python. But if you are working with Azure SQL databases or Delta tables, Delta live tables, so then I suggest you to use SQL, because querying, so writing queries on tables is very easy compared to Python, right? So working with tables, it is easy to write in SQL compared to Python. So in that scenario, you can use SQL. So, but whenever you're transforming or you are creating data frames, then I suggest you to use Python only. Okay. And unified engine. This is unified engine. Okay. Means, so we know, so Apache in this Databricks is unified data processing tool, right? So I mean, if in data team we will have data analyst, so he will create dashboards. We will have data scientists, they will create models, they will develop models, right? So we are data engineers, we will do transformations, we will do many things, cleaning of data. So everyone will come to this Databricks and they can work, right? Because of this unified engine. So this provides library for batch processing and SQL and streaming, graph processing, and machine learning also. So in this Apache Spark, so we can do all this. Because of this only, Databricks is used by data analysts, data engineers, and data scientists. Because of this unified, because Databricks is unified platform, because Apache Spark provides everything. So you can use this Apache Spark for graph processing, machine learning, streaming, real-time streaming, batch processing, and SQL queries. Everything you can use this Apache Spark. Okay, that's right. So next one, yeah, these are sufficient. Okay. Speed. So auto scaling, scalability is there. So it supports many languages and everyone. So machine learning engineers, the Power BI engineers, I mean data analysts, data engineers. So everyone can come, and data engineers can do batch and real time processing, and data analysts can do their building. They can build their own dashboards, and data scientists what they can do, they can do recommendations, and they can okay. So they what they can do, they can write their models and run on this Apache Spark. Okay, yeah. Next, let's see this Apache Spark architecture. So Spark, yeah. So I used one term, right? Master slave approach. So many of you know. So what is master slave approach? So in if you read, if you are a fresher, so you may know what is flip flop. Okay. So in those, if you are aware of this digital electronics, then you may know this flip flop. So in flip flop, so it follows one of the flip flop follows master slave approach. Yeah. Okay, so master slave approach is nothing but the Apache Spark also follows the master slave architectures. So it consists one driver, okay, and we have cluster manager, and the next one is executor. Executors are worker node workers, both are same. So I will use interchangeably. So don't worry. So I mean don't confuse. So this worker and executor both are same. Okay, yeah. So here we have master node, right? Master node or driver node. So you can call anything. Worker node or executor node, you can call anything. Okay. So this Spark architecture is master slave architecture. So master, this driver will, it is like main control unit. Okay. So this master node is main control unit, and the slaves will do the real execution. Okay. So this master node will not do anything. So for you have written some, yeah. Yes, Siddharth.
So the question is like when the number of worker nodes, when do I have to select? It can be only two, or it can be more than two.
No, no,
But
no.
when
It
do I
can
have
be
to
no, no.
select?
No, you can give 8, 7. So the maximum limit is I think 12. So you can take this man. But what happens now? So if you have selected 16 GB memory and you have selected only one worker node, then the memory will be 16 only. If you have selected two worker nodes, then the memory will be 32 GB. Okay. So if you selected 16 GB only, the worker node type. But if you have used three worker nodes, then the memory will be 48 GB. So for 48 GB, you have to pay the money.
Okay.
The
So
DB,
is there any formula to select the number of worker nodes, or
no,
like it
no.
is
So
based?
because while in development or testing you only, so you will come to know this is heavy workload. It is consuming more time. So I should use these many workers. So you will try with three workers. So if you try with three workers, if it takes 1 hour with four workers, it is going to take only 30 minutes. Then you will go with four worker nodes only. So
Is it set at the Spark level, or it is set at the individual program level?
at the so come
I
again.
mean, at what level is the worker node set? It is like at the Spark, I mean, at the cluster level, or it is like,
Cluster level, yeah. So
I
while
mean, all the
creating,
programs will be using two worker nodes only. Okay. I mean, same number of worker nodes.
no, no, no. So that's what. So the cluster will be all-purpose cluster and job cluster, right?
Okay.
So for the all purpose cluster, we have so we will discuss everything in detail. So if you go to compute, you will see all purpose compute and job compute. So job compute, if you have any scheduled jobs, then you will create job clusters. So if you have any real time workloads, then that time you will use all purpose cluster. So this all purpose compute will create clusters. They will run 24 hours. Okay, so but this job compute, whenever the pipeline or job is running, that time only they will be activated. Remaining time they will be terminated. Okay, so this all-purpose clusters, yes, you are correct. So whenever we are creating this all-purpose cluster, so we can give how many worker nodes and how many this one should be there, that we will give, and they are fixed. Okay, while creating this all-purpose cluster, we will give huge memory, and the workers also 7 to 8 we will give. So all jobs and everything will run on this all-purpose cluster. If we configure them to all-purpose, but some jobs needs to be run on job compute only, because if the job is running every day, only once in a day, then we can go with job compute, right? Because here this all-purpose compute is very heavy, because we are using 7 to 8 worker nodes, and the memory also 192 GB. If we run minimum medium data sets tasks also on this cluster, so this is wastage of our resources, right? Then what we will do for those workflows, we will create job compute, and we will give memory as 16 GB only, and the worker node is 1 or 2 we can give.
Okay, sir, got it.
Got it, na? So yes. So whenever there is a need, if the work jobs are running every 5 minutes or every 6 minutes or every 1 hour they are running, then we will go for all-purpose compute. So if those jobs are running once in a day or every 6 hours, every 12 hours, we can go with job compute, because job compute we can give smaller number of nodes, and what we can give. So this will be terminated whenever the job is complete. So we will not pay for remaining time, right? So if the particular job is running only 1 hour for 1 hour, so we can the DBUs will be calculated for only 1 hour. So we'll pay for that 1 hour. Remaining 23 hours, this job cluster will be in sleeping mode. Whereas all-purpose cluster, so if you use them, so these are 24 hours active. So we have to pay. So we have to pay for 24 hours. But if they are consuming resources, they will be paid more. So there are DBUs, right? Here you can see 1.5 DBU. So if you are running something on this one may go to 6 or 7 DBU. So when something is running, when nothing is running, it will be active, but it will consume 1 DBU or something. You understood, right? What I am saying, everyone?
Yes, sir.
Yeah. Okay. What we are seeing, yeah, this DBU means Databricks units. Okay, so 1 DBU will be costed around 1.2 USD dollars. So we will calculate. The Databricks cost will be calculated using DBUs only. Okay, so if you keep minimum, if you keep less workers and less memory, then DBUs will be less. If you keep huge memory and many workers, then DBUs will be more. So for all-purpose cluster, we will keep more memory and more worker nodes, but we will use all-purpose cluster for very high workloads. We will give in job cluster, we will give less memory and less worker nodes. They will be given for medium or frequency, less frequency job loads. So we don't worry if it takes 7 to 8 hours also, no problem, because it is running only once in a day, right? So if it completes in 7 hours also, no problem. Whereas in all purpose, those most important workloads and heavy workloads we will work on, we will configure on all purpose. That don't worry guys, if you are confusing about them, we will discuss in detail about clusters creation and how we can configure everything, we will discuss, don't worry. So this one, so master node or driver node, the main control process in the Apache Spark is this one. So the main control process that coordinates Spark jobs. So we are we are doing the transformation, or we are creating the job, right? So the job in that notebook we will write everything, the code, everything will be written in that notebook. So now first driver will read that code. So now it will read and it will assign that task. So if there is shuffling, or if there is any sorting, or if there is any mapping, so driver node will not do. So it will assign this work to worker nodes. So what it will do, so if first it has to select some columns, so for worker node it will assign that job. Next we have to do some transformation for worker node 2, worker node 2, it will assign that job. So this driver will have the logs and execution only, it won't do anything. It will what segregates the what not job, yeah, it will shuffle, what we can say, correct word. Yeah, schedule. It schedules the jobs to these worker nodes. Okay, it will divide the work to into chunks, and into that chunks, and it will divide the job work to into chunks and schedule the jobs to worker nodes. Okay, so driver node work is, it converts user code, the code which has written in notebook. It converts user code into task and schedules them across worker nodes. These worker nodes will do the exact actual data transformation, data cleaning, data shuffling, everything these worker nodes will do. This driver node won't do anything. It will converts the user code, notebook code into task and schedules them across these worker nodes. Okay, it contains the Spark context, right? So which manages this application. The Apache Spark application will be managed by this Spark context. Okay, then we have this cluster manager. So this cluster manager, what it will do, so this is going to allocate resources for all the applications, for all the Spark applications. It will, this cluster manager will allocate this resources. Okay, okay, yeah. Maybe you have seen standalone and Kubernetes, Mesos, these type of things, right? So this cluster manager will follow up on those. Okay, we'll see the cluster types and the what cluster manager will do while creating cluster we will do. So as of now, so in interviews they may ask you, so can you explain that, can you explain the Spark architecture by Apache Spark architecture? So you should answer like, so yes, it follows the master slave architectures. We have driver and worker nodes. The driver node will do the it will convert the user code, whatever written in the notebook, it will convert into task and schedules this tasks to across worker nodes, and worker nodes will do the actual data transformations and all, and they will send back to the logs. They won't send the they won't send, this worker nodes will not send the what data. So they will send the whether job is completed, this work is completed and not. That logs and execution will be happen between this worker node and driver node. So work is completed, yes. These type of transformation will be there between worker node and master node. So this the actual data and everything will be inside this worker node only. So this will send back to the this cluster manager. Okay. So yeah, so what executor or worker nodes are doing, runs task assigned by the driver. Okay, so they will run the task assigned by the driver node and store computer results in memory or disk. Okay, so these what they are going to do. So these worker nodes will do the computation. I mean, computation is nothing but whatever the task assigned by the driver, they will do that those, and they will store in resulting in memory only, because those Apache Hadoop and Apache Hive, they are going to store in disk, but our Apache Spark is going to store inside the memory only, in RAM memory. Okay, and they will communicate. They will communicate with the driver for the task completion, whether task is completed or not. So they will communicate. Okay, so this is the Apache Spark architecture, guys. If you have any doubts, you can ask me. So you will completely know. So you will maybe it will be confusing, but as of now, remember that it follows master slave architecture. Okay, so we have one driver node and multiple worker nodes. Okay, so this driver node won't do anything. It will divide the task into divide the task, and it will shuffle that task across these worker nodes, and they will do the exact actual data computation, and they will store inside our RAM memory. And whenever they are required, I mean, whenever the task is completed, and it will be sent back to the data frame. So the data frame will have the result of this in memory only. Everything in memory only. Okay. And everything. So these executors will work in parallel. Okay. So they are not working in serial, they will work in parallel. That's why. So if we have multiple nodes, so our work will be divided. And if we have only one worker node, if it is going to take a complete in 1 hour, so if you have two worker nodes, it will complete in 30 minutes. If you have three worker nodes, then it will complete in 20 minutes only, because they are working in parallel. Yes, guys, if you have any doubts, please ask.
I have
Hi,
one doubt.
Abhi, can
Yeah.
actually can you just explain in short cluster manager? You said that it will provide resources to worker nodes. Like what type of resources? Can you just
Yeah, this
explain that?
cluster manager will provide resources means how much, what kind of, yeah, I will show you. So we have general purpose clusters, we have memory optimized clusters, we have storage managed clusters, and we have many cluster types also, and cache driven clusters. We have many types of cluster types and driver node types we have. So those the driver type and cluster type, which are they, and how much memory they should have, this will be provided by this one only. Cluster manage will have those things, those what resources. This cluster manage will provide everything. So what is the driver type, what is the worker type, this will decide. So whenever we are creating cluster, we will select, but this will be provided by this cluster manager only. So what is the type of this master node, what is the type of this one, how much memory it should have, how much memory worker node should have, what is the, whether it is general driver, or this one general type worker, whether it is a memory optimized worker or memory optimized driver, and storage optimized driver, or these kind of things will be managed by this cluster manager. These are the
So,
resources.
yeah, so we will set this cluster manager type or it will set on some
There are no cluster
conditions.
manager types. We don't have, this is cluster manager. So the
Okay.
problem with this one is, guys, so we can't see physically, which is worker node, which is driver node. We can't see physically, but we can feel whenever we are going to create those clusters now. So we will configure them. We will select master node type, we will select worker node type, and we will select this much memory for this master node, this much memory for this one, and these many worker nodes we will select. So everything we are going to select now, then that time we can feel okay, that. So this is the architecture, but we can't physically see what is the cluster manager. Okay, but this cluster manage will allocate resources. This is physically we cannot see, but visually we can understand. So
Okay.
you got it right.
Yeah.
Yes.
I have one question. So, how is the configuration written and provided? And you mentioned right that the driver node will have some certain configuration, worker nodes will have certain configuration. So, how is that rendered to the Apache? Is it
How
through a file or like is it how is that how do we configure, how will Apache know like what will be the configuration of driver and what will the configuration of worker node? I mean, how is that configuration information provided?
we will, so what we will do, so we will know that, we will know, right? So we are, the input file size is this much, so it is going to take this much, so we will configure it, so we can use general purpose. It is no problem, because this is general workload only. So then we will select general, whether the type will be general purpose or not. So if we have memory optimized, because it is use memory, the input file size is use memory, and it is going to transform, it is going to transform
No,
many million
yeah,
records.
I understood that, but like how is that configuration information provided?
Configuration information.
Suppose you need a memory optimized and you need certain configuration of the server for master node, and you need certain configuration of compute and memory for the worker nodes. How is that information provided? Is it through a YAML file or something, or like
No, no, we will select. We have whenever, okay, whenever you're going to create cluster, na, then that time we have drag and drop. So there you can see everything. So what type of what are available here, which one you can select. Everything will be we can see here. We can select which one to select. We can select. We have drag and drop tool. Okay, let me
in
create
production,
config.
like how will we it should be pre-configured in production, right?
Here you can see. Here you can see standard one. See, this is general purpose, right? And if you want to go for this one, general purpose, delta cache accelerated. And if you want to go for memory optimized, you can select these. Okay. So yeah,
No, I got that we have to select this, but how is this information being provided to the in production? Like in production, we have to manually select this, or it is done through some, yeah,
no,
automated
no,
through
no,
an
manually,
YAML.
manually only. So the cluster creation and everything in each environment is we will do manually only.
Okay.
Because in dev environment, so we don't require this much of memory, right? Because we
No,
don't have
but
real
in
time data.
production, like how will we give this information? That is also manually.
Yeah, manually only we will do. So there
Okay.
we won't follow any CI/CD process. We don't have any files for this. We will do manually only.
Okay. Okay. Got it.
Yes.
Thank you.
Yeah. Mm, and what we are discussing? Yeah. Okay. Then yes, yes. Now the actual one, PySpark. So PySpark is nothing but Python plus Apache Spark. Okay, Python plus PySpark is Python plus Spark is PySpark. Okay, so what we can say, so PySpark is the Python API for Apache Spark. Okay, so PySpark is the Python API. So inside, whenever we are going to write inside notebooks, na, so we can see we can have PySpark library, PySpark API. So on top of this PySpark module only, we are importing everything. Okay, so that's why they are saying PySpark is the Python API for Apache Spark. So it allows this PySpark what it does. So it allows users to interact with Spark using Python. So don't confuse that. So this PySpark is different language. No, no. So we have Python. This PySpark is API, one of the API. So for Apache Spark. So we are using Python. We will use Python coding, and we will call this PySpark API every time to do our transformation. That's it, guys. So don't confuse. Okay. So what it does, what this PySpark will do, so it allows users to interact with Spark. It allows users or developers to interact with Apache Spark using Python. We are using Python language only. But what we will use, this PySpark connector we will use to interact with Apache Spark. That's why they are calling it as PySpark. So we are using Python coding only. But what we are doing, so we are interacting with Spark, right? Using Python. That's why it is called as PySpark. That's it. Mm, so why we are using this PySpark? Okay, so why we know Python is widely used in data science and okay, so and Python, so for machine learning engineers and AI engineers and data scientists, they will use Python, right? So they are widely using it for data science, right? So this made PySpark a natural choice for Python developers. Okay. 1 minute. Yeah. So mm, what we can say, about this one. So by Spark. mm, So why we are using Python? This we have covered in first session, okay? Because we have rich collection of libraries, and it supports Python supports library like pandas, numpy. Okay, so everything is supported. That's why we are using Python for data engineering, data science, and everyone. So in every field, it is using. So so for Apache, this one Apache Spark also for Apache Spark also. How can I explain this? So you understood, right? If you have confused, I am also confused how to explain this PySpark. This is nothing but Python plus Spark. We will use PySpark connector. So every time we will use this PySpark module. So on top of this PySpark module only, we will write our Python coding to do transformation and to create data frame. Everything we will write using Python coding only, but on top of this PySpark. Now, what is PySpark? PySpark is the Python API for Apache Spark. Hmm, 1 minute. How can I explain in detail? Mm, 1 minute, guys.
On the top of Apache Spark engine, you write the Python coding.
Yeah. Okay, guys. So we know, so what is Apache Spark? So we know Apache Spark is a very powerful engine used for big data. So that we know. So it can handle huge data sets in a distributed way. I mean, across multiple machines. So we can use. So it is going to handle large data sets because of it can have multiple machines, right? Multiple machines, nothing but multiple worker nodes. Now this PySpark brings the power of Spark. So this power of Spark means this power of in-memory computing, and it is what in-memory computing and distributed computing system. So these features will this brings this Spark brings these features, and Python brings what Python what it is going to bring. So Python is user friendly, beginner friendly, and it can be used in every field. So Python has some abilities. PySpark has some abilities. Now we are using for Databricks, what we are using, these both abilities in together we are using now. That's why this PySpark bring the power of Spark to Python developers. Understood? So our Apache Spark has some abilities, and Python has some abilities. Python is like user friendly, and it has rich set of libraries. Okay, so together, both together, Spark plus Apache Spark plus Python together can do magic. So what magic they can do? PySpark brings the power of Spark to Python developers instead of, right. So earlier we are using Scala or R languages, but now so what we can use Python only. So now due to this Python abilities and this Apache Spark abilities, Python has become natural language for this Databricks. Okay. Mm, So you can think, yeah. So what can I explain? You can think of PySpark as a bridge that connects Python and Spark, guys. So we have Apache Spark. Okay, so we have Python coding. So this PySpark is a, so you can think of bridge that connects this Apache Spark and Python. Okay, So instead of writing our notebooks, instead of writing our code in Java or Scala, we can write them in Python, and we can write them in Python and get high speed and distributed power of Spark. That's why this PySpark is more popular. Okay, so we can write them in Python, and we can still use and utilize the high speed and distributed power of Spark. So that's why. So Python has some abilities. Apache Spark has some abilities. Together we are bringing and together. So we are using this PySpark module using Python coding. That what is it is doing now? This is doing magic because this Python is user friendly and beginner friendly, and it has rich set of libraries. This Spark has distributed computing system and in-memory computing. Both we are using together. So it brings what it brings. We can still do the high. We can still work on the high huge memory and with high speed. We can still work on the huge memory with high speed using both of these abilities. You understood somewhat now? This PySpark is not a different language. We are writing in Python only, but we are utilizing these features, Apache Spark features. So we have whenever we are creating this data frames now, that time you can understand what is this PySpark module, what is this PySpark library. That time you can understand. On top of this, we have a PySpark library. So that library we will use and we will write in Python coding only. But we will use this library. That's it. We have pandas library, we have pyodbc library, we have torch library. So if you are a machine learning engineer, you know all of this. So like that we have PySpark library. That's it. Nothing more than that. So what is this PySpark library? This PySpark library or PySpark API, so it has both abilities, one with this Apache Spark ability and Python ability. So you know what are the advantage of Python, and now you know what are the advantage of features of Apache Spark. This both will in these both abilities are in PySpark. Okay, don't confuse that. It is a language. PySpark is not a language. Python is a language, and we are using this PySpark API. Okay, whenever we are creating those data frames, or whenever we are doing the transformation, that time you can know what is this PySpark connector or PySpark API. That time you can see. Okay, yeah. Some of you understood a little bit. So till now we don't know what is PySpark, right? But now, are you able to think of what is PySpark now? So PySpark is nothing but this Apache Spark, which having this Apache Spark and Python, both of these abilities. And this is not a language. This is a API. So you can say Python connect, PySpark connector, or you can call as PySpark library. That we will see in Databricks. Now, because these are the theoretical concept, guys. That's why. So it will be very difficult to teach you, and it is difficult to understand also. So if you are understanding, then no problem. So if you are not able to understand, go through the recording one more time, and you can search online also what is this. And when you are yeah, so first go through the recording, and you can go through the online content also. Then you can understand much more better. Okay. Now coming to the Databricks. So what is Databricks? You know, so you already read, you already worked on ADF. So ADF is what ETL tool. Like ADF, it is also Databricks also one of the ETL tool, but it is very expensive. ADF is cheap, but Databricks is very expensive. So Databricks is cloud-based platform for big data analytics and machine learning. So, but this ADF is not suitable for big data analytics because it doesn't have it doesn't have any computing, or it doesn't have any Spark, PySpark libraries or PySpark abilities, and it doesn't have distributed computing system like worker and driver nodes. It doesn't have anything. So it will perform some transformations. You may have seen mapping flow, data flows and control flows, data flows you have seen. There you can do joining. But if it is medium set, if it has 100 rows or 1000 rows, then okay, you can do it with this ADF. But it has some some lakhs of rows or lakhs of records, then it will be very difficult to do on ADF. It will perform, but it will take 1 hour, 2 hours. So whereas in Databricks, it will complete in 2 to 3 seconds, but in the ADF will take more time. So have you did this one on ADF? I mean mapping that joins are creating. I mean derivative columns are. Have you performed this one in ADF? Have you seen how the pipeline, how much time it ran, how much time it took to complete that pipeline? Have you experienced, have you noted, any one of you? Because you already completed ADF course, right? So if the table has 100 rows, to shuffle or to join, how much time it took? Only in ADF, I am saying, not with Databricks, only in ADF. Have you done data flows in ADF? Have you used ADF for data or means data shuffling or data joining or data transforming? Okay, leave it.
Yes,
Yeah,
yes, Gopi. We used
yeah.
to do that actually, and it was taking more time. Even we have few rows, you can say 10 rows of there, and we were doing joining, and it was taking around 50 seconds or 1 minute, more than that.
Okay. So, but if you perform, so we will see in real time, we will see, even though if it has 1 lakh rows in PySpark, in Databricks, it is going to complete in 15 to 20 seconds only. So same, we are going to work on Databricks, right? So same, you can transform using ADF, and same data you can transform using Databricks. Then tell me. So you both, you are aware of both tools now. Now tell me after 20 or 30 days. So you tell me after completion of this course. So you tell me. So do the some take some what unified. So which can be done in ADF and Databricks. Take some task, create one pipeline and perform that task in ADF, create one notebook and perform only on Databricks, then tell me how much time they are going to take. Okay. Yeah. So Databricks, yes, it is a ETL tool, cloud-based platform, and it is suitable for big data analytics and machine learning. And so the good thing is it is built on top of Apache Spark. Okay. So it is built on top of Apache Spark. So we can enjoy the whatever the feature it has in memory computing, auto scalable, speed, flexibility, and everyone can, so every can work, and we can do collaborative work on this Databricks. Okay, so all these features we can enjoy on Databricks because it is built on top of the Apache Spark. So okay, so it provides, yeah, I told na, so it is unified engine. So unified engine means it supports batch processing, it supports real time processing, it supports machine learning, and it also supports graphical processing. So that's why, so anyone can work, I mean, so it provides an interactive environment for, so data engineers, data scientists, and data analysts, and all they can collaborate, nothing but it is unified platform, we can say. Apache Spark is unified engine, and Databricks is unified platform. Okay, so let me write what are the yeah. So don't think because this Databricks is nothing but it is built on top of Apache Spark. So Databricks will do whatever we have discussed till now. So Apache Spark, whatever the characteristics or feature it has, they can be. So the all of those features are in Databricks. Okay. Now, so managed, the features of the key features of Databricks are managed Spark clusters. So yeah, because it is built on top of Apache Spark, so no need to configure Spark manually. So because if you want to create data frames in Jupyter or Google Cloud, then first you have to what you have to run the Spark session. First you have to download that say Spark one, and you have to connect to Spark. But in Databricks directly you don't need to start that Spark session and all. So because this one is built on top of Apache Spark, right? So other tools other than Databricks, they have to initialize and they have to start the Apache Spark. But so Databricks is built on top of Apache Spark, so no need to manage, no need to configure the Spark manually. Okay. Yeah. So I will. So tomorrow we are going to create data frames now. So you try to create in Databricks free community edition, and also you try to create the data frame in Jupyter or Google Cloud. So what is the difference? You have to tell me. So in Friday session, okay. So the task for you is on Wednesday we are going to create data frames. That time we will create in Databricks Community Edition. So you go and you search online, or you can use any charge, any GPT or AI support. You take any support and try to create them on Google Cloud also. So now tell me. So what is the difference in creating? Take same data frame name, everything should be same. You have to create the same data frame in both Google Cloud and Notebook. So then tell me the differences, what you found, how much time they took, much time it took on Databricks, and what are the connectors you have to you have to manually configure them in Google Cloud and the notebook in the Databricks notebook. So everything you have to tell me. Yeah, so managed Spark cluster means so it is built on top of this Apache Spark. No need to configure Spark manually. So we can enjoy the Spark, whatever the Apache Spark has, that we can enjoy. And then auto scaling and auto termination. So what is auto scaling and auto termination? So auto scaling means we know, so we can create job clusters, right? That time, so you can increase the what you can yeah. So in cluster also, in all purpose cluster also, you can go anytime, and you can, once you create the compute na, so you can go anytime and you can increase or decrease these. On weekends we don't have real time so much data, right? So on weekends we will not have so much data. That time you can keep the worker nodes to minimum, and on weekdays you can give them as maximum. So you can auto scale them. Okay. And one more thing, what auto termination. Auto termination means we have job cluster, right? So the job cluster will be created. The job cluster will be created whenever the job has started its run, and it will automatically terminated. So there we are efficiently using the resources. Okay, what we can say, efficient resource usage. Okay, so efficient resource usage means, so this auto scaling I have explained. So whenever we don't have, so on weekends we can keep the worker nodes to minimum, I mean 3 or 4. On weekdays we can keep maximum. That we can do in auto scaling. Auto termination means, so in we can create job cluster for some jobs which are not frequently running. So we can create those jobs which are running on job cluster na, they will be auto terminated when the job is completed. So we are not wasting the resources whenever the job is not running. So whenever the job is not running, resources are not utilized. So that is efficiently. So we are efficiently using the resources. Okay. Yeah. And the feature is collaborative notebooks. Collaborative notebooks means, yes, though in Databricks, I told you. So Apache Spark, it suppose flexibility. It has flexibility. It suppose Python, SQL, Scala, or Same Databricks also built on top of this one. So you can write. So you can write the code in the same notebook. You can write for some 2 or 3 cells. You can use Python. Whenever there is tables, we are working with tables for some cells. You can use SQL. And if you are good at Scala, you can use Scala. And if you know R for command, for some transformation, you can use R. So so we can use any language. So it supports multiple languages: Python, Scala, SQL, and R. And the next feature of Databricks is Delta Lake. It has Delta Lake. So I will explain what is data lake, what is Delta Lake. So what are the asset transactions? Everything we will discuss in Databricks classes. Don't worry. So we have Delta Lake. Delta Lake means the schema. So it supports schema validation is there. So if yesterday we have updated column. So if that type is string, so next day also it must be string only. So okay, so it should not come as date type. It won't accept. That is schema validation. So this Delta Lake will support will have that structure of the data it has to follow, and it supports only what structured data, not CSV file, not semi-structured, and it won't allow images, videos, and all. So data lake will allow. Data lake is nothing but ADLS. Inside ADLS, you can store CSV, you can store Parquet, you can store images, you can store videos, and you can store text files. You can store tables also. But in Delta Lake, Delta Lake is built on data lake only. Both supports huge volume of data. But in data lake, we won't worry about structure. We don't worry about schema. So you can store images, you can store CSV files, you can store everything. But in Delta Lake, you can store only structured data, like tables only we can store in Delta Lake. So this Databricks has Delta Lake. You can see what is Delta Lake here. If you go here, so here you can see catalog. So inside catalog, you can store some tables, right? So we have iMeta store. Under this, we can store some tables. So we call them as Delta tables. We will discuss everything. Don't worry. Yeah. Next one. Yeah. So Databricks has built-in MI and AI supports. Okay. So it integrates with ML flow for model tracking and development. So data scientists, they do this. They use this machine learning. These right. So so we have, so Databricks support this ML and AI one also. So we have built-in ML and AI support for Databricks, so that data scientists can do their modeling and ML flow and everything they will do, and they can build their own models. Yeah.
Shashank, can't we use Azure Data Lake and Databricks with same, like if I want to use Azure Data Lake instead of this Delta
Hmm.
Lake, can we do that?
Yes, yes, yes. So your name, Darshan?
Divyang, like
Divyang.
we
Okay.
need to use Data Factory and Databricks, both the things, I think, at that
No,
time.
no, no, no. So whenever you are connecting to ADLS from ADF, that time you have used link service, right?
Yeah, yeah.
So here you will mount we will use mount point. So we will mount the,
Oh,
from Databricks we can mount the mount to the ADLS location, and we can read and write easily. So compared to ADF in Databricks, it is very easy. We will have
oh,
4 to 5 lines of code, and if you know storage account name, and if you have storage account key, then we can mount that account storage account to our Databricks, and you can enjoy the whatever the features ADLS has. That everything you can read, write, and you can do everything like whatever you did on ADF.
okay.
Yeah. So SQL database also, to Azure SQL database, you are using link service. Here we will use JDBC connector or ODBC connector we will use. And to that JDBC connector, we will give the table name, the storage account name, and the host name, I mean SQL server name, everything we will provide those credentials, and we can connect to those databases, and we will work whatever the way you worked with SQL database from ADF. Same you can work from this one also, Databricks also. That's why I am saying this Databricks is ETL tool, because every time, so the raw files will be inside ADLS only, right? So we can connect to ADLS and we can read the data, and we can process the data using Databricks, and we can transform and clean it. And at last we have to load the data. So where we will load the data? Sometimes in Delta Lakes, or sometimes in databases, or sometimes to the external. So this one exporting also, I mean loading also we can do using Databricks itself. We don't require ADF at all. But the problem, so we enjoy the features of ADF and Databricks, because so for extracting and loading we can use ADF, because Databricks is very expensive. So the link service, they will cost us very we can get them at very cheap rate, but Databricks is more costly. So that's why we use it for transformation and extracting and orchestration, and pipe this one, what loading and everything, we can use ADF. Okay, and the what okay, these are the features. Yeah. So okay. Mm, yes. Mm. So Databricks architecture, right? So Databricks. mm, So in Databricks architecture, so the main components are control plane and data plane. So in Databricks architecture, so whatever in SpicePark architecture, we have three components, right? So one is master or a driver, other one is executor or worker, and the third one is cluster manager. That is whenever you are going to explain PySpark architecture, so you have to remember those three components. One is driver, other one is worker, and the other one is cluster manager. So whenever you are going to explain a Databricks architecture, now that time, so you have to explain control plane and data plane. Okay, this control plane will be managed by Databricks. Okay, so here you can see. So this will be managed by Databricks, and the data plane will be runs on our cloud provider. So users cloud provider. Okay, understood? This will be managed by Databricks. Okay, Databricks cloud account. So whatever maybe Azure Databricks we can see. So this will be managed. This control plane will be managed by this Azure Databricks account, and this data plane will be managed by so customer cloud account. Okay, any confusion?
No, sir. Thank you.
Yeah. So this one control plane will be managed by Databricks, and this one will be managed by this one cloud account or cloud provider. Inside control plane, what we have? So inside control plane, we have notebooks. Notebooks are repos, and we can see job scheduling, and also you can see cluster creation and termination. I mean cluster management and web application. We can see in control plane. Okay. So what you can see inside data plane? So the data processing with Apache Spark clusters. Okay, so this data plane, so data execution, so execute Spark jobs, and this virtual machines are what we can say worker nodes. So worker node, we have data processing with Apache Spark clusters, right? So this means, so we have worker nodes, right? So worker nodes will execute these Spark jobs in data plane only. Okay, so this data processing and data loading and data reading, everything will done on data plane only, because we can, so you can see data, we can connect to data sources on data plane only. Okay, and Databricks file system also. So DBFS also we can connect in data plane. So so can access data from multiple sources. In data plane, we can access to data source multiple resources like we have ADLS, right? Azure Blob Storage, ADLS storage, and S3 bucket, Delta tables. So we can connect through them. So in data plane only. So that's why actual data processing will done on data plane only. Okay. So I will elaborate it 1 minute. Um, what we can say about this control plane? Yeah, so this one is managed by Databricks. Databricks means AWS or Azure or GCP. So they will maintain this one. So they will manage this Databricks. And what they will do, so inside this control plane, so managed by Databricks and controls orchestration, management, and security of the Databricks workspace. So Databricks workspace means this one. Databricks workspace means this one. So this will be managed by Databricks only, na? So I mean, this one Azure, Microsoft Azure only manages everything of this. Okay, and what they are going to do. So orchestration is nothing but this one. We have workflows, right? So this workflows will be comes under control plane only. Okay, so management is nothing but this one, compute and creating cluster, everything will be on this management only. And security, so who can access this one, you can see here settings and privacy and everything you can see in this settings and privacy. So this will be managed by control plane. Okay, and this control plane will not store actual data. So actual data, everything will be stored in data plane only. Okay, because this from this data plane only we are connecting to resources, and we have worker nodes in here. So they will perform the actual data processing, and they will be sent back to the data stores again. So what I'm saying, so does not store your actual data, but what they are going to do, they are going to manage, they are going to manages metadata, jobs, and cluster configurations. Okay, this control plane will not store the actual data. Which one will store the actual data? This data plane only, because they are connecting to data sources. Okay, so let me explain one more time. So this is managed by Databricks. Okay, I mean Databricks is nothing but AWS, Azure, or GCP, and they controls the orchestration, management, and security of the Databricks workspace. And they don't. I mean, it does not. The control plane does not store actual data. But what it is going to do, it is going to manages metadata, jobs, and cluster configurations. We have seen that. So cluster configuration, this compute, jobs, this workflows, so everything. So will be managed by this control plane. Okay. It includes what they includes, what data planes includes, this sorry what this work control plane includes. It includes Databricks workspace. So it includes this Databricks workspace. Okay, so it includes cluster manager, so this compute, and it includes workflows, I mean job scheduling, everything. And it includes Unity catalog, we haven't discussed, we will see. And also, yeah, and they also, yeah, workflow workspace is nothing but notebooks, right? So notebook and query execution management they will manage, they include. So in control plane, notebook and query execution management and controls execution, but does not run the actual computation. Okay, I will tell you. So what it is doing, so actual computation, everything will be inside data plane only. But what control plane will do, so it will controls execution. Okay, it is not going to do, control plane is not going to do actual execution. They are going to control, that's it. So they are going to control the execution, what has to run first, which worker node has to run first, which worker node has to run this task. That will be the logs and execution will be inside the control plane, but actual data will be inside data plane, and actual processing will be done inside the data plane. So any doubts about this control plane? If you have, I will explain one more time.
I have one. So the metadata of the data is stored in the Azure, in the Databricks cloud account, but the actual data is stored in the customer cloud account.
Correct.
Can you please explain this? Because both are connected, right?
Yes.
So why it has been done like this? Why is the metadata of the data is also stored in the customer cloud account? Uh,
Databricks cloud account. So one more, come again.
so the metadata, why is not the metadata stored in along with the data in the customer cloud account?
Mm,
Because they are very tightly connected, right?
Yes. So one thing, so this Databricks architecture is nothing but control plane and data plane. Both are inside of the Databricks only. Okay. So both are inside the Databricks only. So if you go to here, I will explain more detail. Okay. If you go to catalog, so here we have some tables, right? So this schema. So this everything here, if I go to, I don't have any table to show now. So this will be handled by this. What is the structure? How many columns are there? The structure will not be worried by. So data plane, what it will do. So whatever, you don't worry about so if it is date type or string type, or it won't worry. So because actual processing is running on this data plane, right? So it worry about the data. So it won't worry about the metadata. So who will worry about this metadata? This Databricks cloud account. Otherwise, what we can say, inside this catalog, yeah, here. So inside this catalog, if you go, so here employees external table. Yeah. So here we have sample data, na? So sample data, details, history. This will be managed by the this Azure account, and the data, sample data we have now, these two will be inside the our cloud, our account, our user account. And these details, this whatever there we have now, so name, age, one more time, name, age, and the type, everything will be inside the what control plane, I mean Databricks account.
Yeah, but why it is that two accounts is required? I mean, is there any and between the two accounts, is there any network required, or like it is
No, no,
in the
there is no
same
network.
place?
They are this both what we can say. They are already connected. Data control plane and data plane both are connected. So what it is going to do? This control plane, our Databricks cloud account is going to manage our metadata, but this data plane will not going to worry about this. What is the type? What is this? I mean, you understood, right? What is the structure of this? It won't worry. So our cloud account will not worry about this one. So Databricks cloud account will worry about this one. So and but both are connected only. If you see, these both are connected only. So they have interlink. So but this won't worry. So if it is going to remember everything, so it is going to check all every time. So we have millions of records, right? If it is going to
But
check every time, it is date type of string type. It is, we are burdening this, right?
if there is millions of record, then if there is a bit, if these two accounts are different, I mean, won't there be slowing down the process? Like because every time they have to switch two accounts to check the metadata and the record, each record within a millions, within a table which has million records.
I understood, but they are connected. But whenever we are loading, that time only, if you are created, I mean metadata, inside metadata, if that schema is date time, if you are going to insert anything other than date time, na, so it won't allow. So that's why this data plane will not worry about the structure or schema. So this Databricks cloud account will not allow that invalid rows. So that's why this data plane should not worry about the inside what is the data type and what is this everything. It won't worry. This
Okay, got
Databricks
it.
cloud account will itself won't allow the invalid rows. It will tightly checks the data type. Everything will this will do. If
Okay.
both accounts are going to do this, na, then we are burdening both of the accounts, right?
Okay, so it is schema on. It is the schema on read.
Yes.
Okay, okay, got it.
Yeah. So yes, next, yeah. So you understood, right? What control plane is going to do. Now I am deviated what I have to explain. Yeah. So it is going to manage. It manages. We have Databricks workspace, cluster manager, job scheduler, and yeah. So these all type. These all are managed by this one, right? What Databricks cloud account. So these are all comes under control plane. So now what data plane will do? So where our data, actual data processing happens here only. So we have executor node code, what executor nodes, right? So executor nodes, what they are going to do. So they will they will execute our code and they will run our jobs, okay, inside this data plane. So our executor nodes are going to execute the whatever there in the notebooks, and the actual data processing will happen in data plane. So yeah. Yes, what we can say. So actual data processing is happening here only, and actual execution is happening here only. And this data plane, it connects with data stores. So that's why. So it will read the data and it will load the data. So it will read from different data sources, and it will process the data, and it will send the execution and logs and other information to control plane, and it will send back the data to this one only. So it will, this data plane will store the, first it will store the data from data sources, and it will do the execution, and it will store inside in memory. It will store in memory. Whenever the job is completed, that time it will send back the data to external sources. Otherwise, if you are going to store them in Databricks itself, they will store them inside the Databricks only. So how can we store them inside Databricks? In catalog. We have catalog, right? So here we can create them as delta tables, and we can store them as internal data tables. So this data plane is doing this job. What it is doing? So it will read the data from different data source, and it will get the what. So it will get the communication from this control plane. Which worker node has to do this one it will do, and actual data processing, actual data and everything will done on this one, and it will send back that. So yes, this job is completed. It will send back that logs and execution. It will send back, and the whenever the job is complete, execution is completed, either it will send back the data to other data sources. Otherwise, it will store them in Databricks only as in memory. So and in memory, otherwise we can call as in catalog. In catalog, it will store them as what, internal tables, internal delta tables, and does not send your data to, yes, it does not send our data to control plane. So what it will do, only logs and execution details and execution metadata are sent to the control plane. Okay, so control plane will not have the actual data. What they have logs and execution only. So the actual data and actual execution will be done on data plane. Okay. Any doubts, guys? So
So far, so good, sir. Thank you.
this one may be helpful for you. So you can see. So feature, control plane, and data plane we have. So this is managed by. So Databricks is managed. Okay, stores data. Feature, yeah. So managed by, yes, feature. These are the features, and this is control plane. What control plane will do or not, this data plane will do or not. So this is managed by Databricks. Control plane is managed by Databricks, and data plane is managed by your cloud provider. Okay, and the next one, control plane stores data. No, control plane will not stores our data. Data plane will stores our data. Okay, and handles UI, notebooks, and jobs. Yes, it will handle yes, logs and execution will be handled by control plane, and data plane will not have this one. So jobs, notebooks, handles UI. I mean this one. jobs, notebooks, handles UI, compute. This one will be handled by control plane only, control plane, not by data plane. So run Spark code. So which will runs our code. So actual data processing is done on data plane, right? This one. So not on control plane. Access to cloud storages, we know. So actual data processing will occurring on data plane. That's why. So access to cloud storage on data plane only. So stores execution log. This will, so data plane will every time this worker nodes will send the execution logs and metadata to control planes, right? So it stores execution logs and it stores actual data. So actual data and data processing will done on this one. It stores the actual data. So any doubts on this one, guys?
No, sir. Thank you.
Yeah. So, guys, it may be because it is 1.5 or more than 1.5 hour of theory class, right? It may be boring, but it is very important. So, I suggest you to go through this one more time, and if you have doubts, you can Google it because so because these are the architectures. So in interviews, they will ask you about these architectures. So if you go through recording, you will understand 50%. If you go through, if you go and if you read itself on yourself, now then you can understand much more better because these all are not physically I will show. These are all visualizations, right? That's why I suggest you to read yourself only.